Hi, everybody. Today's talk going to be on policy enforcement on Kubernetes with OPA. So let's get started. My name is Alex Sol. I'm a senior platform architect at Pivotal. My Twitter handle is Alex Sol.
And I'm Jaime. I'm also work at Pivotal as a platform architect. And today we are going to cover a few topics related to OPA. It's primarily an introductory session. We want to pique your interest on OPA, and hopefully you learn a few things that you can apply in your organization to help with policies. I'm going to start with an intro, and then Alex is actually going to do the cool stuff. But let's first clarify OPA stands as Open Policy Agent. It is an open source project that is incubated in the Cloud Native Computing Foundation since, I think, March 2018. And now, before we jump into the details of what OPA is and how it works, I want to take a quick moment to talk a little bit about the problem at hand and what OPA is trying to help with. So when we talk about OPA, we're really talking about policies. Policies understood as any set of rules that govern our software, applications, and services, right? And really, everybody is affected by policies in the stack, whether you're working with applications, tweaking authorization, you're managing your data grid, you're going a little bit lower, managing Kubernetes, and you need to control with more controls on the images that you manage, or closer to the infrastructure, or even managing the CI/CD. You're affected by policies, especially if you're in a regulated industry where things are a bit more complicated. Now, let me walk you through one specific use case. Let's just say I'm an application developer, and I'm tasked to work on a new API. I need to create an API that provides some salary information for certain individuals. And well, the first time I provide the first iteration of my application, I set some authentication based on some guidelines that I received from the compliance team. But soon after, new policies need to be set, because there is a new group that needs to get access to this salary information. And I need to tweak slightly my application, because yes, I'm using Spring Security and JWT tokens, but I still need to tweak a little bit my application to decide, okay, this group of users of this individual needs to really see the salary, but not these others. But then a new policy comes in, and I need to change it again, because one of the groups that needed to access the application need to see slightly less information because the policy has changed. And then the policy changes again, and I need to roll back some of those groups. So I pretty much changed my code 3-4 times without really providing any business value. I spend time and cycles that I could have spent doing something else. And this gets a bit more interesting when a compliance team, a team that is in charge of watching for all these policies, really depend on this application developer to, of course, making the changes, but also to have a good understanding and view of what are the policies that are applied in the systems. And when you export that to all these other use cases that we have, everything gets obviously much more complicated and inefficient. I was just highlighting one use case on the application stack, but you could really extrapolate many of the other use cases. And in fact, Alex Sol is going to talk deeper into the Kubernetes use case. So what is OPA doing to try to help on this problem? So the first thing is going to help you decouple the policy from the software, from the applications and the services. So in a way, ensuring that as much as possible, all these policy changes are not affecting the code. You don't have to recompile or publish any new code just because the policy is changing. And at the same time, allowing all these teams that are more in charge of keeping the policies across the entire stack to know exactly what's there and to actually be the ones that own it and the ones that change it. Second thing that OPA is trying to do is trying to unify and centralize the policy definition and to facilitate the enforcement on those policies across the entire stack. And the third thing I would like to highlight is that thanks to the fact that OPA provides you a way to declare these policies, you can really have a policy as code. And this allows you, obviously, to have better management of these policies. You can put it in source control. You can keep track of all the changes that happen to any given policy, go back to an older policy and roll back, etc. Anything that you can do really with source control. So let's take a quick look now at how, at a very high level first, and then we'll dive a little bit deeper on how OPA works. It works as a general purpose policy engine. And essentially, it helps services to offload the policy decision. When the services provide a request to the policy engine in a JSON format, OPA is going to be able to read that query and apply any of the policies that have been submitted into OPA and provide a decision, so that we are definitely extracting that decision process of the policy from the code. And to take a quick look at the example, which is tied to what we were seeing before, in this example we have again an endpoint to get the salary information, in this case about a person called Bob, and I'm identifying myself as Alice. The service is basically mapping the domain information into a JSON structure, is passing that as a query to OPA, and OPA is making a decision, true or false. And now it's time for the service to enforce that decision and decide, okay, this person can or cannot access this service. Now, these services can be multiple things. We saw a few examples in the first slide. We'll see more ahead in the talk. But again, it could be this service as an API gateway that is enforcing the authentication into your microservices architecture. It could be another type of custom service. It could be a Kubernetes API service, as we will see next. Or it could even be a task in your CI/CD pipeline that is checking things to make sure that policies are also applied during the testing and the integration of your software. And at the end of the day, the list can be much longer. If you think about the constraints here, this service just need to pretty much describe its domain information in a JSON format and pass it to an engine, which could be integrated as a sidecar. It could be a daemon. It could actually even be a library, but the first two are the most common ways to integrate with it. And just interpret and output in JSON format. So potentially that service could be anything, because these days most services are capable of defining information from their domain in a JSON format. Now, one of the important things that makes all this possible is the declaration of the policies. To do this, OPA uses Rego as the policy language. With one of the main objectives is to make sure that these policies are easy to read and easy to write. We want to make sure that you don't spend tons of cycles in writing policies that are too complex and that also are very difficult to read them and understanding they're valid. You obviously need to put some testing into your policies, but it's far better if a human can read a policy and make sure that it looks correct. We already said that it's declarative, and this is going to help the owners of the policy to declare policies and tell the system what needs to be done and not how it needs to be done. And even if we are going to show you guys a couple of policy examples that are fairly easy. Rego is prepared to actually manage policies that are complex, that have complex structures of JSON. In fact, in the Kubernetes example, we'll see that the information that the policy can actually read gets a lot of input from the Kubernetes API. It can be a hierarchical, complex JSON structure. The good thing there too is that it doesn't have to change depending on the part of the stack you're working on. So you don't really need to add modules or anything just because you are using OPA, Kubernetes, or the API server. This is one example of a policy, just for you guys to have a quick understanding on how it looks like, Rego. What this policy is essentially doing is going to deny access to a given resource. So the decision that the policy is going to do is to deny access if pods are not using a container registry based on huli.com. So what you guys see into that deny bracket and that block is basically a set of statements that they are ANDed together for evaluation, and where the actual assignments are always true. So whenever that it is true, we will actually respond with a message that, in this case, the Kubernetes API will be able to decide not to allow that resource to be created. Now, before I hand it over to Alex, just wanted to show a diagram of all the areas of the stack where OPA can actually be leveraged. We talk a little bit about the microservices APIs. That's a very, very common and I think very easy to understand use case. We are going to dive deeper into the Kubernetes use case using admission controllers using OPA integrated as an admission controller. But there are other areas where there are actually tutorials and information in the documentation to integrate with. When you might be wanting to apply OPA policies also at the lower level when you want to decide who can access a server, and you can integrate OPA if you have SSH and sudos using PAM. You can also apply the same principles of OPA with data filtering and protection. The use case there will be around the lines of pretty much filtering the amount of data that can be extracted from a database, or filtering in time. If it's a reporting system, I only want to allow certain users to access 5 months of reports, for example. And then on the risk management space, with Terraform, there are ways to improve the quality of the changes that Terraform is going to do by eliminating a little bit the human factor and validating a Terraform plan and connecting Terraform with OPA to do validation on Terraform, so that you really can be checking with a finer grain control what changes are going to be done in the infrastructure. Okay, and with that, I'm going to hand it up to Alex to talk a little bit more about Kubernetes.
Right. Thanks, Jaime. Right. So to get started with the Kubernetes use cases, let's consider what the lifecycle of API request to Kubernetes API server looks like. So when a request comes in to the Kubernetes API server, there's actually an API HTTP handler. So Kubernetes API is written in Golang, so it's a HTTP handler that takes the request and basically says, hey, are you a really valid HTTP request, and can I pass you sort of up the stack? The up the stack, we have authentication and authorization components. So this will vary a little bit by the cluster and how it's implemented, but it's typically through some type of backing services to say, hey, the request is coming in. I identify by looking at the token that it's done by user Jaime, and does Jaime actually have access to be able to call this API endpoint? And if that's good to go, there's essentially an optional component, or you can register your webhook targets that can receive. These are essentially custom software that can take a webhook from the Kubernetes API server in the form of the actual request and say and mutate them. So the mutating webhook controllers will essentially allow you to mutate the spec. So an example may be, let's say you're in an enterprise and you obviously have some type of an HTTP proxy, or you don't allow direct connectivity to the internet. So you may not want each individual user to kind of bake that into the pod specification. You may have a controller that looks at the specification and says, hey, every time you see a pod being created, inject an HTTP, HTTPS proxy environmental variables in there. Or another common use case may be injecting, if you have your PKI infrastructure and you have your enterprise root CA, you may want to maybe inject them through some type of volume mount, as an example. And these are executed in serial. So if you have multiple mutating admission controllers, they get executed serially, one after the other. But once that's gone through, now we have a valid schema, a schema that needs to be validated before it's presented to the validating admission controller, which gets executed in parallel. And these are basically a binary on and off, right? Do I allow this specification to be created in the cluster? And once stacks go through, the data is actually persisted in etcd. So this is how the request kind of goes through the API stack and gets written into the persistent stores of Kubernetes. So a use case may be my colleague Jaime has a really, really great application called Cool App. And I gave him some access as an operator of the platform saying, Jaime is a good developer. I trained him on Kubernetes a little bit. He should be able to go deploy his application. So Jaime has been working on Minikube for the longest time, or in his development environment, he's used to using service type load balancer, which may be OK in a dev environment or like developer sandbox, but probably not a good practice if you're running in a cloud provider, right? It may be incurring some additional expenses, and out of the box, you may actually get a public-facing IP address, which you may not want in an enterprise location. So because I gave Jaime access, this process goes through OK, and essentially the application is deployed. But I really wanted Jaime to not use this practice where the load balancer type is actually service type is actually load balancer. So in order to do that, I can implement my custom admission controller saying, hey, every time a request comes in, if the load balancer type is, the service type is load balancer, I'm going to deny you, right? I'm going to throw a message saying service type load balancer is not allowed. Jaime will see this message, and he'll have to change his service type to cluster IP. And basically, my custom service controller will say, OK, you're good to go now. This is a good practice. I allow you to do that. One thing you notice is that within the authentication RBAC scheme of Kubernetes, essentially, the authentication is binary. I can tell Jaime to create a service object or not, but I cannot say, I cannot make enforcements just by using role-based access control within Kubernetes. So what happens is my use cases expand. Now Jaime created his cluster IB. He'll probably want to create an ingress object to kind of have a application load balancer kind of expose this to the outside. Maybe he's used to testing this on his laptop and he wants to use a fake DNS. But if he was to, say, throw this into my production cluster now, that may be a serious issue. So I go through the same process again, and I expand my application, my admission controller to adhere to this use case. As you can see, this keeps getting more complicated. I have to maintain more rules in my application. Essentially, this custom ingress admission controller would either be a different piece of service that gets deployed onto my cluster, or it's essentially the initial controller had to expand the use cases. So before you know, I'm consistently maintaining this large system to be able to allow or deny these policies. Again, if I were to enforce this, the code will take a look at it and say, hey, you're not allowed to create www.acme.corp or acme.com, but you can create, say, qa.acmecorp.net as an example. But all I really wanted to do is really express some type of a policy in a specific language that I'm familiar with, or and be able to have care about the policy itself rather than the actual runtime concerns, right? Because when you look into the runtime concerns, I may need to care about every time Kubernetes makes some changes, I may need to validate it against it. I may need to care about scalability of this. I may need to make sure that it's performant, et cetera. Open Policy Agent can basically be a Swiss Army knife that gets injected into the runtime and can allow me to specify these in an object format. So I don't have to care about the actual Kubernetes integration with my admission controller and the use cases around it. So I can just, instead of having a specific runtime environment, I can care about the policy itself and have the Open Policy Agent get injected there. And as I have more use cases, I can build up on these policies and add new policies that will be able to facilitate that. So with that said, I believe I have so a couple of other use cases to talk about is, I talked a little bit about the service type load balancer, but you can also do things such as, hey, if the service type is load balancer, you have to have an annotation saying that it can be private only, right? So a lot of the cloud load balancers allow you to have, by default, it'll create you a public IP address. If you're in an enterprise and you don't have public-facing applications, or deploying a public-facing application is a bit of a more security risk, you may want to enforce everything to be a public IP address. Other use cases are registry whitelisting and blacklisting. Jaime talked a little bit about this, but a lot of our customers will have their own internal registries where they'll have security scanning, various different compliances around it. So they want everything to be coming in through their enterprise registry that may have some compliance requirements around it. Ingress tends to be a common use case as well, which domains you can specify the ingress to, forcing users to use TLS in their ingress, etc. Maybe other use cases. And also policy validation. So network policies in Kubernetes allow you to specify what ports, essentially it's network ACLs that you can assign on a pod basis. So you can also build rules around these, right? So maybe the application owner should be able to specify what port the application should be able to talk to, but they shouldn't ever embed something like SSH and allow port 22 into it, right? So you can basically build in these policies that block certain ports of certain services to never be allowed into those servers. So with that said, I'll do a quick demo, and I'll be going through a couple of different scenarios here. So I'll show you my enterprise. The demo workflow itself is about whitelisting registries. So with that said, I'll do a quick show of our enterprise registry. So I actually have this Spring One Nginx image, which is basically the vanilla Nginx image. And I have it deployed to both Docker Hub, which is hosted here under my alexsol/Nginx repository. And I also have this in my internal registry that's hosted by my friend Jaime here. One of the cool things about Harbor Registry is that it allows scanning for vulnerabilities, right? So if you were to think about it, it kind of does like, hey, what are the packages that are deployed in this container? Does it look good, etc. So the idea is you can have your enterprise registry enforce some of these things, and before it gets into the cluster, it may get validated. And I do also have a cluster deployed here. So if I were to do kubectl get nodes, you can see that I actually have a live system that I can talk to. Wi-Fi seems to be running well, and I can actually get some information on it. So the way things, I do have a namespace here named OPA, and this is where we deployed our OPA, Open Policy Agent controller. So essentially, it's running within the cluster as a pod. It basically gets, we do have an admission controller. Oops. Sorry about that. There we go. And it gets registered as a validating webhook configuration that basically allows me to define to Kubernetes, hey, every time you get you essentially get a workload, send this workload internally to the pod that's running in my cluster. And so this is functioning fine now. I don't really have any policies deployed to it. So I have this policy that I created that basically looks into what the kind of the request is. So if it's deployment, replica set, if it's a pod. So the pod use cases tends to be a little different because it's not typically a single object. Typically the workflow would be somebody creates a deployment, that creates a replica set, that creates a pod, or somebody may create a pod directly. So essentially it's chained in a way that whether it's a replica set or a pod set or a pod or a deployment, it looks into the specification of the image and makes sure that the image is coming from this approved enterprise registry. Those don't need to be hard-coded into the registry. You can also basically build these on other Kubernetes objects. So there could be implementations where you can actually have those annotated in, let's say, a namespace. So namespace may have something like allowed registry equals registry name as well instead of policy. So there's some flexibility around it. But what I can do is essentially deploy this policy using a config map. So the Open Policy Agent, as it's available today, is using config maps for generating the configurations. There's a new project called Gateway in the Open Policy Agent ecosystem that allows you to specify those as custom resource definitions instead of config maps. But once the config map is deployed, so once I essentially took that file and shot that to the cluster, now if I were to basically deploy my application. Let's try this from. So what I'm going to do is I'm going to try to do a kubectl run from the Docker Hub registry. And you can see that immediately I get a denied error saying the actually registry is not allowed for my environment. If I were to use the approved registry, well, let me see if I can find this in my history. There you go. If I were to use the approved registry and hit run, then you'll be able to see that the deployment gets created, and the pods will be starting up shortly. So this allows me to have policies based on that. And that's the end of my demo. So to cap up, the Open Policy Agent allows you a lot of flexibility around being able to build your enterprise enforcements in a flexible manner, where you can define them as source controllable objects and keep expanding on it. There's a lot of literature around the actual Open Policy Agent website. There's a lot of sessions around typically KubeCon. That takes place around the Open Policy Agent implementation and usage, and there's various different tutorials. So,
thank you, everybody. And I guess we can take a couple of questions if anybody has.
Yes.
Right, so the question is, what is the most common use case with OPA integrated with applications? Okay, so the most common use case is normally around authentication. Because at the end of the day, OPA is trying to help you making decisions based on some information. And you potentially could delegate and offload more decisions to OPA to make for you. The one that makes more sense based on the information, based on the focus of OPA is to apply policies which at application level, the most common denominator would be authentication and who can see what, right? But technically, you could really expand it for other things. You have other type of policies in your organization that are commonly applied when users are trying to access endpoints of an API. You potentially can expand that and include more policies to extend the number of decisions you're offloading OPA to make for you. Okay. More questions?
Does it look like vendors are getting behind the use of policies to replace or augment the products like a SiteMinder or things like that to enforce policy?
Want to take that? Well, the question is, if we think that vendors are falling behind the implementation of policies, like falling behind in the sense of not incorporating enough features on their. Okay, yeah, that's a good question. I'm not really sure. I think I'm not sure if one of the purpose of OPA is really trying to fill that gap, rather than probably make a unified way to apply those policies. So I'm not really sure. Yes.
Where can we learn more about the language, Rego?
Yes, so the question is, where can we learn more about the policy language, about Rego? I would definitely start on openpolicyagent.org, because you will see, you will understand Rego the way it is used in Open Policy Agent. There's more about Rego out there. We really didn't put any link there about Rego specifically outside of the Open Policy Agent, but there are resources out there, so it's easy to Google it. If you're interested in OPA, I will start with the openpolicyagent.org, and there's a section dedicated to Rego, and obviously expanding on all the type of the things that you can use to really inspect JSON and so forth. So it can get really complicated on the type of JSON that you can manage. Yeah. Yes.
So how does this scale to, like, if you have 100 namespaces in your organization? Like, is the agent running in, like, default namespace and applying it across all of them? All those policies?
So
Yeah, sorry. The question is, at scale, if you have hundreds of namespaces and hundreds of objects, how does the scale work? In general, I'm not sure what the largest scale the customers run this in, but it's essentially a rendering engine that'll take the JSONs and kind of apply the rules. So one of the benefits is that you kind of offload that responsibility of runtime performance to a team that maintains the project, and you trust them to do that performance validation well. That said, you could probably introduce some latency to object creations if you're not super careful with it, but in a system such as Kubernetes, I'm not sure if you specifically care about how long it takes you to create a pod, whether it's 2 seconds versus 2.5 seconds.
there is also, just to complete that, there is also a budget that can be set for a policy application that requires really high performance. And I think I haven't really read enough to see how it applies to the Kubernetes use case, but in the API use case, it can go up to 1 millisecond. Like, the decision really needs to come in within 1 millisecond. Otherwise, it's not acceptable.
Right. And it's a stateless application, so you should be able to scale it up linearly.
I was more concerned with, like, where the agent is actually running in the, like, is this just gets applied across all, like, policies applied across. So, like, if my team, like the platform team, is saying you can't put load balancers into any namespace across the entire cluster, like, is that the intention? They're basically saying,
Yeah.
like, the way it works, like, each team has its own namespace, like QA, prod, and we're applying objects across that. So I'm just wondering, like, I kind of think the platform should be kind of making it clear that you can't just load balancers over that.
Yeah. So the question is around, I guess, basically, is the requests namespace? Then if you have a sort of a controller that needs to be deployed per namespace, and basically the registration is not namespace, so it's cluster wide. So all the cluster level concerns will come in there. But you can also build rules where they are, say, if you own the creation of a namespace, you can assign tags to it, and then you can, in your policy, you can refer to those tags to be able to build logic for it. So an example may be if you say enable load balancer equals true in the namespace, and your developers cannot create namespaces, then you inheritedly, basically, you may have some namespaces that the policy allows things to go through. But yeah. Thanks.
Okay. Any more questions? Well, thanks everybody.
Thank you.